What's up guys, this is Masi. Welcome to my channel. In this video I want to talk about dynamic equilibrium. All chemical equilibria are dynamic equilibria. A dynamic equilibrium is an equilibrium in which the rate of forward and reverse processes are equal. So it means that we have forward and backward or reverse reaction, and both of them, the rate of the reaction for forward and backward are equal. To help picture a dynamic equilibrium, imagine 18,000 people attending a sport event. Most of them are in their seats for most of the time, but there are always about 400 people at the concession stands buying snacks. This means that on average 17,600 people are in their seats. Throughout the event, people continuously move back and forth from their seats to the concessions, but the total number of people in each area remains constant. Since it is a closed system, we can therefore describe this as a closed system in dynamic equilibrium. Why is the chemical equilibrium always a dynamic equilibrium? To answer this question, consider a chemical reaction between steam, H2O in gas phase, and carbon monoxide, CO in gas phase in a closed vessel at a high temperature. The balanced equation is like that: H2O plus CO gives H2 plus CO2. Assume that we start with equal amounts of carbon monoxide and water vapor. From a balanced equation, we know these substances react in 1:1 molar ratio. Therefore, if we start off with equal concentration, the concentration of these two gases will always be equal. Similarly, since hydrogen gas and carbon dioxide are formed in equal amounts, the concentration of these gases will also always the same. Under the conditions of the closed vessel at a high temperature, the chemical reaction begins immediately and progresses very quickly. And figure 2 shows the changes in the concentration of reactants and products of this reaction over time. This is the chemical reaction over time, and you see here the concentration of CO and H2O is going down over time, and the concentration of carbon dioxide and hydrogen is going up over time. Notice how as the concentration of the product increases and the concentration of reactant decreases. At the time indicated by the dashed vertical line in figure 2, which is here, the concentration of reactants and products remain stable. This is the point at which chemical equilibrium has been reached, and no further changes in the concentration of reactants and products will occur. So as you see here in this reaction progress, so concentration over time, the concentration of reactants reducing up to the point called equilibrium, and the concentration of products is increasing up to a point that we call it equilibrium. And the concentration of reactant, also the concentration of products, is not changing over time after equilibrium condition. So changes in concentrations over time when equal amount of carbon monoxide gas and water vapor are allowed to react in a gas vessel, in a closed vessel. So this is basically what we call dynamic equilibrium. It means that although we have chemical reaction in both forward and backward reaction, the concentration of the reactants and also the concentration of products is not changing, and we can say that the rate of forward reaction equals to the rate of backward or reverse reaction.